Okay, so let's move on. 5.2, 3 and 4. Mechanisms. Mostly done quite well. And as I said during the course, they're very picky. So this is where those 3 A4 sheets of yours that we made and in the front of your folder are going to come in handy. That will continue, by the way, possibly while you're still doing some self-study. The outline of the mechanism for 5.2. You can see I've double checked at the bottom. I've asked myself, does it need to be from the dead center of the lone pair? Yes, it does. That's the extent of how picky they are. That arrow starts dead center on that lone pair, and that minus should be above the oxygen. Now, technically, you wouldn't get penalized in this case, but let's get in the habit of putting the minus on the oxygen. Yes, that's the feedback on that one. Mostly I was quite pleased with your mechanisms, actually. Those who, if you got marks in the mechanisms questions, you got like almost all the marks. There's a sort of big gap, so well done. Second one, I'll just leave you to look at the mark scheme, really. Elimination, and it's a base. Yes. 5.4. I've been quite harsh with your comparison of these two compounds or molecules. We're not talking about the property of bromine or chlorine. We're talking about the property of the carbon to chlorine bond versus the carbon bromine bond. And that is only a 1 mark question. You just need to state that the carbon to bromine is weaker than the carbon to chlorine bond. Let's see what we're going to do next. 7.123. Yes, very badly answered 7. Which shows us that the bonding topic is continuing to cause some difficulties. I think our year 13s pointed out that bonding and lone pairs and stuff is still causing them some issues, so you're not the only ones to be struggling with that. I'm going to go through it on the board. 7.1. You're used to doing hydrogen bonding diagrams with water. Not with that pen, though. So you start off like that. We'd want to draw in the partial charges and the lone pairs. The marking is a bit complicated for this one, by the way. If we were doing water, we'd do that. Now, in this case, with water, it doesn't really... There's 2 hydrogens there, both bonded to oxygen, so both could be involved in some hydrogen bonding. Look back at your bonding booklet if you're not sure what I'm talking about. It was that orangey colour, big and fat, tricky stuff. Now we're not doing water this time, we're doing methanol. We're doing something that has loads of hydrogens on it. So a problem a lot of you have had is you've mistaken which hydrogen's involved in the hydrogen bonding. Well, these are irrelevant. Ignore these. And in fact, in the mark scheme that you're going to see, you'll see they haven't actually been drawn out at all. Okay, so you want your oxygen and your hydrogen. The relevant lone pairs are on the oxygen. In fact, there's no other lone pairs. Okay, so if I can start off like that, I'd be getting the mark that first bit. However, there is another picky thing in this one, in that in this is a more recent exam paper, they want them all in the same line. They want that atom and the atom on the other molecule that we're hydrogen bonding to be in one straight line. So to make my life easier, I'm not even going to draw it like that. I'm going to think a little bit about bond angles. They wouldn't be too picky about that. To make life easier, I'm going to draw that out like that so that we don't even risk getting confused. Oxygen, hydrogen. My approach to one of these would be probably to draw that and then fill out the delta plus and delta minuses. But the oxygen now is in a straight line away from there, which, if I'm going to keep up my nice angles, is going to leave this looking a little bit odd. There's the H that comes from that oxygen. There's the CH3. Okay. Oh, I've done it again, haven't I? Yeah, I even put that dot there, never mind. There's the H that comes from that oxygen. There's a CH3, whatever. So it's 1 mark for getting all of your partial charges and all your lone pairs on that are relevant. That isn't relevant. That's not relevant because look, they're not involved in where the bonding is. And our lone pairs actually I'll make sure that one's facing the way it's about to go. I'll make sure it's clearly facing what I'm about to do. These are partial charges, lone pairs, H bond, straight line. Okay, straight line between that 1, 2, 3. There's 1, 2, 3 atoms. Any questions? Let me know in the comments. Okay, 7.2. This was now very badly answered. The description of why the angle has been reduced. Well, it's only 1 mark. Okay, you've only got 1 mark for explaining why this bond angle is less than in something else that's got 4 pairs of electrons. And you simply just say that lone pairs of electrons are going to repel those bonding pairs more than a bonding pair would. Okay? If you're not sure what I'm talking about, go back to the point where we compared this sort of thing. I think we actually compared water. So, look, we compared water to methane, CH4. So that might be something to do. Okay, that might be something to do there. Okay, moving swiftly on. 7.3 was awfully answered. Draw a structural formula of the position isomer of butan 1-ol. Do not draw butan 1-ol. Butan 1-ol would not count because you need an isomer. You need a different arrangement of the atoms. The other thing is it's asked you for a structural formula. I'm going to rub this out now. It's asked you for a structural formula. You can either draw a list of atoms, or you can draw showing all the bonds. If I were you, I'd show all the bonds. You'll see this in the mark scheme. If you're going to draw the structural formula, what we would ideally see is A is evidence of where the branch comes in, or where the thing comes off the main chain, like that. Okay. Okay, so that's showing me the structure because it's showing me the bonding arrangement. It's not showing me all the bonds, so that's not a problem. What some of you have done is this method. Wait, this is more old-fashioned. Oops, I don't mean seriously, do I? And I don't believe it's actually accepted. Okay, so don't use that method with a bracket for a branch. Use that first thing that I showed you, and you'll see in the mark scheme. Okay. What's next on my list? 9.1 and 3. Okay. Well done to quite a few people who have no names haven't I mentioned yet. Alishba, Reese, Gurkapal, Ikra, Ali, and Ikra Karen. Well done for knowing the definition of periodicity. It's a set of repeated trends. So, did I bring my periodic table? You repeat what's going on. A precursor to the idea of the periodic table was the idea of octaves. Those of you who are musically minded, you've got octaves, haven't you? You've got the C and then a C above it, where the pattern starts to repeat every 8 notes. You can see it easily on a keyboard. Well, the whole idea of this thing is that we have that repetition. We've got a specific pattern going across here. As things get bigger, suddenly at a point where they get bigger again, the pattern repeats itself. So that was a repeating trend or pattern. You'll see that in the mark scheme. And that again was one of the ones you were teaching yourselves, one of the self-study topics. So again, make sure you learn definitions, even if it's not one I specifically wrote on the board in class or whatever. 9.3 is a bit picky. Carbon was your answer, and it must be the superlative. So read the question carefully. it asks you for a specific set of atoms. It's not asking for the whole of period 2. It's which out of those ones are in period 2. You needed to say that of them, carbon had the smallest number of protons. Carbon was the smallest. You wouldn't get the mark for saying the trend is as you go across they get smaller. Okay? Someone's just coming in. We're nearly there. Aluminium, we're not going to do that one. 9.6, 10.3 was actually, a lot of you did this one very well. You certainly get your marks for saying, as usual, look for a moles calculation you can do. So you've got a lot of words. You've got 4 marks in front of you, and you can definitely get some marks for working out how many moles of something there are. Okay, so I do recommend that nice big grid method for doing that, working out what's going on. So well done to Ikra, Ali and Neshi. I liked your grid methods. So yeah, I'll leave you to look at the mark scheme and see how this one works, but there's a couple of grids you can make to do that. Okay, any questions, hit me up in the comments, and I can, if there's lots of the same question, I can do another one of these about that specific question. So the more you engage, the more I can help you with what specifically we need. Okay, there are a few other notes I need to give you. Oh, so as I say, usually these videos will be about content. Okay, I've just finished going through that paper. Usually I'm going to give you something that you could learn. You can just look at it and learn that thing, like the one I did yesterday. With this one, I'm giving you a few more logistical things, but I'll try and keep that to a minimum. However, there is a job I'd like you to do to demonstrate that you have participated in this. So for lots of our lessons, there will be something you need to email to me. The thing you need to email to me, please, is a typed up answer, in full sort of paragraphs, not bullet points, a new typed up answer to question 2, in which you have achieved 6 marks because you've looked at the mark scheme. So look at the mark scheme, go over, make your corrections, achieve 6 marks in it, type it up and email it to me. Okay, and I'd like to have a look at it. If you don't hear back from me, it's because it's 6 marks. Okay, otherwise I can email you individually. What you're going to need to do with it, you might need to type some equations. Bless you. You might need to type some equations. So you might need something like that. That's got your superscript and subscript in it. Don't worry if you haven't included superscript and subscript. Okay. There's a handy little keyboard shortcut for doing it on Microsoft Word, which is Control and equals, then type. And there's also Control Shift equals and type. Okay. And those are your shortcuts. But if yours looks like this, that'll be fine. Oh, and I think there's one thing I forgot to say about that question. You don't get any marks for writing an equation about silver and fluoride reacting because they don't react. Okay, those 2 ions don't do any reaction because the 2 halves of the equation are the same. The state symbols haven't changed, so you don't get any marks for that one. Okay, regarding repair work, there's not a specific activity, but what you could do, and I'll post this again in the forum, you could have another go at the homework we set you before the key assessment. Okay, so you could have another go at that. Right, I think that's everything. I can post more if I've forgotten something, but look back in the comments for the rest of what I need to do this lesson. Okay, thank you.